those of you who have For those of you who have just joined, sorry, I didn't start recording. Hope my audio is getting back to normal now. And let's try to run this quick recap exercise on pandas merge. This will be still relevant in SQL, or even more so in SQL. What is the final result of this merge operation? I am merging them based on the ID, and what is the result of that? Feel free to type your answers in the chat. How equals to inner, which means that I am matching a record if and only if the ID appears in both of the data frames. I'm not supposed to have any entries, any ID that's not in either of the data frames. So which of them match this criteria? B, and yes, that's the answer. So this is the tricky part about inner versus left versus outer join that we're going to cover in further details. But intrinsically, when you're trying to merge two different data sets, two different data frames, two different tables, sometimes you're like, okay, some entries are in one of the table, but not in the other one of the table. How do I handle those situations? And that's how this how operation in pandas is specifying. And the inner join versus left join rule is the same thing in pandas and SQL. How is this scenario going to be handled? And in this first option A is actually an example. It's actually the result of a full join, which means that okay, as long as ID appear in any of them, from the first one I have 1, 2, 3. The second one I have 2, 3, 4, and as long as ID is as long as any of the record has ID, I'm going to put it in my final result, even though I don't really have a score for some of them, right? I don't really have, oh, sorry, I don't really have a name or score for some of them, but I'm still going to put it in. On the other hand, this one is an example of left join, which means that okay, I care more about the left table, which is the first table I have here. So here I have 1, 2, 3, and then Alice, Bob, and Charlie. I don't really have a matching score for Alice, but that's okay because I mean the left table, Alice, Bob, Charlie, and ID 1, 2, 3 is what I really care about. So in this case, this is the result of the left join. This is the result of the full join, and this is the result of inner join. As you can see, by specifying this parameter here, your data is going to change. And I wouldn't say like, oh, you should always use what, you should always use what. It really depends on what do you want with your data. Okay, that's some quick recap of pandas operation, and we're going to see something very similar and learn how to do this thing in SQL. So this is copied from my own material in week 6 with some addition. So this I had done a little bit of preview, but I guess some of you weren't here at that time, so we're going to run it again. So what is SQL? Like, it's called SQL because it's a standard query language. It's basically the language you go to for database management, for data transformation, and query data. It's not exactly pandas, and a lot of people will say, well, it's kind of not exactly a programming language because it's only working with data. You're not going to work with SQL for something like video streaming. For example, in like Python, you could do things like PDF editor. You could do things like, what else? Like video, you could do like game development in Python. You can do a lot of basically everything in Python. But you're not going to do game development in SQL. I mean, I wouldn't say you couldn't. It's Turing complete. Like, something, if some language is Turing complete, you can do it in everything. But it's not something you should be doing. In some sense, you could do like you could run a complete game development in Excel in spreadsheet, but that doesn't mean you should, because it's created just for data. And some of you, when you're going through like some online materials, when you're maybe asking ChatGPT or asking, Googling, okay, how do I query this thing? How do I run this in SQL? You may say, oh, hold on. There's MySQL, there's PostgreSQL, there's TransactSQL, there's NoSQL. What are they? And what are the differences? Well, intrinsically, SQL is kind of like this industry standard way to query a language. It's kind of like you have PDF file or you have something like Word. You have different editors, but all of them work slightly differently. So the most fundamental difference is that MySQL was basically made for Oracle databases, and PostgreSQL is open source general purpose like language, SQL. And I would say for the sake of this course, you don't need to worry about them. Yes, there are some functions that's only available in PostgreSQL but not available in MySQL. There are some operations that's only available in SQL Server, for example, pivot, but not in Otter SQL. But most of the time, you will worry about that when you hit that. Like when you say, oh, when you think this function, when you copy one example from online tutorial or like one maybe like Stack Overflow or ChatGPT, and like, hold on, why is my editor telling me this is a syntax error? Well, maybe you need to check your SQL version, but that's a different story. We don't need to worry about for now. So why do we ever need SQL? Don't we already have pandas? What's some problem that pandas couldn't solve? Well, pandas is great for small scale analysis, but panda doesn't handle transaction consistency and isolation of database very well. It's not designed for database. What do we mean by transaction consistency and isolation? Well, you might have not like encountered this scenario, but for some other operations, for example, forward fill or merge, sometimes your pandas could execute for minutes. And what if you have another operation that you're doing at the same time? Well, sorry, pandas couldn't handle that. And if your operation, your merge operation or your forward fill operation fail in pandas, your data frame will be partially filled. It will say like, okay, some errors happen halfway. There are some parts that's completed. There are some parts that's not completed. And that's a huge problem in database management because, well, you change part of the database, but not all of that. That's breaking the consistency rule and so on and so forth. Pandas is designed for data analysis and small-scale data transformation, but it's not something you should be using when you're working with a huge database. And for those of you who's interested in web development, yes, you could run like pandas data frame as your backend database, but that's not recommended. In modern software architecture, you should always have when you're building like an application, usually you will have a front end where the user is interacting with the UI and like rendering and so on and so forth. A backend where your functions when you're a programming language like Python, Rust, maybe C++, Go, or whatever language you're using, is handling the request and compute. And also another place, the database should handle all your data in transaction. And this database should be able to handle like multiple transactions at the same time. Because, well, think about it. Your Google Chrome or like YouTube is handling like 1 million or 1 billion requests every second. And can you really do that in pandas? The short answer is, well, maybe I'm not good enough to know that. Sorry. But the answer is no. Pandas is not designed to handle like 1 million requests or 1 billion requests at the same time. You need to execute one request and the next one and the next one, even though like some of the requests could be executed simultaneously in SQL. So that's why we have different tools. for this purpose. And also, pandas will start failing or falling apart when you have gigabyte scale of data. Depending on your computer, if your computer is really good, like you have like 96 gigabytes of RAM, maybe you will hold a little bit larger. But in general, if you have like 5 gigabytes of data, 10 gigabytes of data, your pandas might start crashing. But modern data processing framework contains like, for example, YouTube holds like petabytes of data per day. And a lot of the enterprise applications holds like terabytes of data per day. If pandas is failing at that scale, we need different tools. And that's why, well, we do have a lot of different tools like Koalas, like PySpark, like Databricks, a lot of different tools to handle these things. And yes, a lot of them are written in different language, but most of them would offer a SQL like API, which means that, well, as long as you are working with data, you should be able to use SQL along the way. Even so for pandas. For example, I can run this operation. Well, I'm not supposed to do this here, but I can run I can run the same thing with SQL with df.query API. Select something like this. Star from df where age is greater than 30. This is equivalent to the statement above. Some people still prefer the pandas API because, well, it's shorter. Some people like to use the SQL API because it's more readable. It's a personal choice, but yes, the SQL APIs for pandas is there. So the real reason we're trying to introduce SQL here is that we're trying to just introduce you the go-to language for data in 2025. And yeah, without further ado, let's dive further into SQL and SQLite 3. So for this class, we're using primarily SQLite 3 because it's easy to install. You don't really need another like weird bundling of application out there. It's an open source SQL package written in C, yes. Underlying the SQL language is written in C. It's one of the best options for small scale database. It's in memory. And it has millions of active users globally. Like by default, if you start your Django backend servers API in Python, your database by default is a SQLite 3. And remarkably, it's only maintained and developed by 3 developers. I was actually shocked when I first learned that, like all 3 of them are extraordinary developers managing like this I think it's well, maybe close to millions of lines of code with only 3 developers. It's a fascinating job they did. And also, okay, this graph is a little bit small, so I'm going to enlarge it. It's not the best quality, sorry. So, a little bit more about SQLite and SQL in general is that SQL is not part of pandas. So if you go into your computer, there's some part of the computing resources that's allocated for your pandas application. There is another resources that's like allocated for your SQL operations when you are running this SQLite model. So what does that mean? Is that, okay, your Python is, well, the Python you write when you execute your Python code, right? Whenever you tell your Python code to execute SQLite 3, what it did is that, okay, I got a Python request, I need SQLite 3. This Python is going to send a request to my resource manager telling him, okay, I need to wake up my SQLite here, somewhere in my computer. So your Python will go to open up SQLite 3 for you. And this SQLite 3, well, you can run like query and different operations within your SQLite 3, but a lot of those operations are not executed in Python. This is one of the distinctions we have to know here. A lot of the commands you're executing or see in the homeworks or the class materials are actually Python telling SQLite 3 to execute this command. Okay? So this is where you're exchanging, okay, I need to execute these things, and the SQLite3 package is going to tell the database, okay, this is the operations I need. So far, so cool. And we're going to break down some of the comments a little bit further. So maybe you have seen like this very similar operations in the class material. But the easiest way to invoke an SQLite3 is to just set this object con, kind of like short for connect. You're setting this object connect to a specific database. Okay, and I believe you can also run it with. Feel free to check out the like course material for an alternative way. You could run like with SQLite3 that connect blah 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 as con and do something. It's basically the same thing other than well some tiny difference. And inside this connection object, this is well one of the objects, you can create another cursor object, a smaller object inherited from this connection. So basically this connection is telling, okay, I have this object here that is going to work with all of the operations related to SQLite. And this cursor is, think about it as a worker, or your mouse click is also named a cursor. This cursor is going to be the place where you tell your connection, okay, these are the commands I need. So let's see some more examples. So when you see cursor that executes, you're telling, okay, Python is telling SQLite cursor to execute this command. Create table if not exist, user, blah, 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 blah. And the second one is, okay, this one is basically telling SQL to create a new table here inside the database. And next one is, okay, this database is created, but it's empty. It's imagine like you create a spreadsheet and you name, okay, this is a user spreadsheet, this is a user table, but it's empty for now. There's no data there. Now, the next command is telling, okay, insert into this record into my table. Nothing magical here. And here we have a commit. Why do we need that? Well, I think I have written somewhere here. Yes. The cursor that executed will tell the cursor object which SQL command to be executed. It will execute a command in memory, but it will not change the database until con, the commit, is called. What does that mean? Well, an analogy I have here is that you're kind of like writing the Python code without saving if you don't write this con, the commit. What it does is that, okay, these two executions are executed, but the final result is not saved into the database yet. So if you close the database now, all these changes will not be saved. Is that clear? And we'll also need to use like fetch all. Well, and also remember, all of these results do not exist in in Python yet. When you execute something like cursor to execute, or even after you commit all the changes to the databases, these changes, these data, they only live inside the database. The Python has no access to them up to this point. If you want the Python to have access to them, you need to use fetch all, fetch one. I believe there's another command called fetch or something like that to actually do the job. So let's see this example. So in complete code. So here I'm just connecting to the database, telling my pit. Actually, I'm just going to run this. So this command is going to create a .db file. If you open this .db file, chances are you're going to see some random code there. That's normal because it's encoded by SQLite3. It's heavily compact, but this is where your data is going to sit. Okay. So this part is just telling SQLite3 to just, okay, I need to use this database, and if it doesn't exist yet, just create it. And this one is telling, okay, I'm going to use this cursor to execute my SQL command. notice that I could change it to whatever name it has. Okay, and now I'm executing, dropping this table if it exists. I want it to be like fresh, brand new, and I'm committing these two changes into my table and select the results, print it out, close the connection, close the database, and then the next time I'm opening the database, I should still see the result. Well, it should be 1, 2 Alice, not 1 Alice, because I committed the change. As expected, I committed a change. So, yes, are you saying something? Do you have a question? Nope. So when you here, when we execute this, we're getting the results. We close it. The next time, because we commit that, the next time I am running this query, I'm expected to get the same result. Now, what if I commit down the commit line? Can anyone try to make, oh, this is wrong. Can anyone try to make a guess? What will the second print statement give me? Do I still have this same result or no? It's everything is exactly the same except that I'm no longer running this con.commit. Question. Do I have the same result as in here? Type 1 if you think the result is going to be the same. Type 2 if you think the result is going to be different. Do I have the same result if I execute this still? I am dropping the old database, creating a new one, insert data into it, query that, and then close my database. And then now I am going to the same database and select the same thing. Do I get the same result as here or no? Type 1 if you think, okay, I will have the exact same 2 lines printed out here. Type 2 if you think the result is going to be different. Anyone? Make your best educated guess. Logically, what would it be? And what's the difference with a conduct commit and without a conduct commit? Saving to DB, yes. So the second one, am I saving anything to the database? And if it seems like I'm not saving anything to the database, right? Because I did not run this conduct commit. So if I do not save to the database, what will stay in the database after I close it? Yes, I write some additional stuff into my database, but I did not save it. What will my database have if I open it the next time? I write a bunch of code in my Python file and I didn't save it. I closed the file. I didn't save it. What do I have when I open the file the next time? Anyone? If I don't save a file, what do I have the next time I open it? Nothing. And that's exactly what we got here. So far, so cool. So when you are working with database, please remember to save your result if you really want to write to your database. Database persistence is actually a very common issue. Like I've seen like a lot of bugs arise because, oh, yeah, sometimes like it's supposed to update the database with commit, but this line of commit is forgotten, so the result is just not updated when we're executing that the next time. Because we didn't save it, the next time we open it, we will have empty result. And the same thing will, this is a huge problem if you're writing a database for, let's say, a shopping system. Hold on, why is my shopping cart empty after I added that? Well, maybe there is some bug in your database operation. Maybe you forget a conduct commit statement somewhere. Okay, this is a very common mistake in SQL. Okay, so now we have kind of understand the basic architecture of SQL and how do we ever interact with that in Python. And I will also want to point out that you don't always need to run this type of cursor.execute. There are many different ways to execute what SQL code. For example, I could open like my SQL terminal this way. And yeah, do I have, let's see, create table if not exist. I can run all of the command here, but it's not the most efficient way because it's not a good editor. Similarly, I could also save all of my SQL commands into a .SQL file and execute the .SQL file. That's actually a recommended approach. If you have a really lengthy like SQL command. Or another way you could run, okay, what if I don't want to break them into multiple different, like line by line? I could just run cursor.execute. I could use the multi-line feature of Python and run my SQL here. I could do table users. You have many other ways to do the same thing here. Okay, it's the same thing as this line here. This is actually the recommended approach then, breaking them up line by line. And if you really have like multi-line SQL, like 20, 50, I would say if you couldn't really fit that in like one tiny cell, then maybe you should write it in a separate .SQL file. Okay. Let's see. And also here, for the sake of demonstration, I am setting up my cell a little bit differently, so I'm configuring that so I could just run the SQL command directly in the cell. If you are using Jupyter Notebook, this is something you could do. Depending on which Jupyter Notebook environment you have, you might need to install additional packages. Anyway, so after we understand the basic working of SQL, we're going to dive a little bit deeper into the basic syntax. So fundamentally, 90% of the time, your SQL command is going to start with these three queries. You select, choosing the columns and the rows. It's going to retrieve the data from the table, and you could just name it like whichever name, like here, if I want the age, if I want the name, I could select it by name, as long as it's separated well by comma. And I can also use star for all of the columns. The next item, the next keyword we need to know is where. It's for filtering. And it's basically filtering like, okay, age is greater than something, if my salary is smaller than something, if my, let's say, sometimes you could also combine, is my date is greater or before or later than one specific date, I could work around with that. And this is going to work before aggregation. So we haven't talked about aggregation first, but we'll talk about it slightly later. So we also have join statement. It's basically the same thing as td.merge. And here we're going to reiterate again what's the difference between different types of join. If you have a left join, you're going to keep rows, all the rows from the left table, and if there's no matching records from the right table, those entries will be NaN. On the other hand, if I'm using right join, that means, okay, my right table is the most important thing. I'm going to keep all of the records, all of the rows from my right tables, and if I don't have matching records from the left table, they will be NaN. And finally, inner and full join. Full join is, okay, maybe some of them is only in the left table, maybe some of them is only in the right table, but I want all of them. And inner join will only give you the result that, okay, they appear in both of them. So far, so good. Of course, these are not all the operations we have. We also have things like union, intersect. Intersect is actually less common than you think, but yeah. Feel free to, well, SQL itself has been evolving for decades. We're not going to have enough time to cover all of the possible syntax here, also because of different flavors. So feel free to dive deeper into that. So today we're going to run quickly with this example demo database. So I have this department table, and I could select only one column, or if I want both of the columns, I could do it this way. Nothing special. This is the same thing as selecting star from the department. Okay, I could add another where, let's say, department ID is greater than 10. Something like this. Or let's say greater than 10. And what if I only want them to be ordered by something different? I could just tell it to run order by depart ID, DSC, descending or ascending. Something like this. This is kind of a more complete SQL statement. But one advantage of SQL is that well, advantage and disadvantage is that it's a little bit more verbose than pandas. More readable, but a little bit more lengthy. But it's more readable. And another thing I want to point out is that the sequence of your operation is not the same as the internal order of code operations for SQL. What does that mean? I could have department ID like, let's say, dummy ID. I'm going to say, hey, can you actually do that? The answer is yes. From department where dummy ID greater than 10. Put it this way. Hold on. From select department ID. Background of this error. Yes, because this name is not created yet. Something like this. You could do something like this, and one tricky thing is that, hold on, this dummy ID, can I select something that's not already in the data frame? The answer is yes. And you can also run some other functions here. For example, let's see. It's going to be a rabbit hole, but there are some things you can run when you're selecting a new columns. Put it that way. Let's say I can also run basic numeric operation is totally fine. I could also run like rounding. I could also run like percentage or quantile or whatever. There are some functions you can run here and some function you can't. We're going to further details for those stuff next week. So don't worry about that so much. This week is mostly about familiarizing yourself with basic SQL. Now we have another table. And notice that I'm not changing, when I'm running this, I'm not changing my database. Okay. Notice that the original database is not changed at all because, well, I'm not writing any like alter table or insert into statement. When I'm running select, I'm not really like changing anything. And hold on. So this is just to show you what the employees table is looking like for now. And here we're going to run a little bit of inner join. This might look a little bit confusing. Okay, hold on. What is e.name? What is d.department name? Hold on a second. Why do I have something like this? Well, this is what I want to emphasize a little bit earlier, that in SQL, the order of your code, you may say, hold on, I'm defining E here. Yeah, I define my E here, but I'm using it before I defined it. Is that okay? Yes, it's okay because for SQL, this part of the line will be executed first before this select. Even though when you're writing the query, you write a join command after the select command, but internally for SQL, for a database, the join is run before the select. In SQL, the order of your code is not the actual code, like order of code operation. If you want, you can dive into, there's something called a SQL like execution plan. This is something you could potentially optimize yourself, but that's a very complicated thing, and we're not going to go into detail for that. But remember, in SQL, the order of the code is not the actual order of operation in the database. So what is this doing is that, okay, I'm aliasing, I'm calling this employee table E. I could also run like employee.name, but it's too lengthy. So a lot of time we just shortcut it as E. There is an optional S statement here you can run, but most of the time I would prefer not to run it. So here in the joining statement from the first table, so this is going to be your left table, and the right table is your department. Okay, I'm selecting the name from the employee table, the department name from the department table, and joining them based on, okay, their department ID should be the same. So far, so good. This is a little bit more confusing when I first started learning SQL. I was like, okay, why am I using this before I defined it? It took me a while to actually get used to it. So here, let's take a look back. So let's see this one by one. Employees table is here, department table is here. Okay, I'm joining them based on department ID. Department ID of 10 is here, 20 and 40. Okay, 10 and 20 is in both of the tables, so there will be the final results. I'm selecting the name, Alice, Bob, and the department name, the HR and finance. Great. Can I add other stuff into the table? Yes, as long as it's in both of the tables. So let's see. I'm going to add d.dpd ID. Department ID1, and then e.db. Two. You can see that they're a perfect match. We're matching if ID1 equals to ID2, and if ID1 and ID2 are both there, we're going to select them into our final result. So far, so good. Okay, now let's move on to left join. For left join, as we kind of argued above, when we're doing the left join, we're going to prioritize on the left table. So let's see. I still want the name. I still want the department name. But here, I want all of the department from employee table. I want all of the records from the employee table. So well, there's something that doesn't really have an employee ID, but that's okay because, well, I want all of the table, all of the records to appear here. I want Alice, Bob, Carol, David, and all of their department ID. Well, some of them doesn't really have a department ID, but that's okay. I still want all of the records. I don't want to drop any of the records. They're really important. And let's take a look back into the department ID. Okay, I don't really have 40. I don't really have 30. Like 30, department ID 30 is in my employee table, but not in the department table. But that's okay because I care more about my employee. Hopefully, that's what employers think. So you're going to see none, sometimes NaN, sometimes like Na, sometimes null, depending on which version of SQL you're seeing. But that's basically your left join. You're prioritizing the records from the left table, and you're matching them with whatever that's there in the right table. But if there's nothing in the right table, just leave them blank. So far, so good. You could also run the same operation in pandas. You'll notice that they're actually kind of similar. Any questions so far? Okay. So, in the remaining time today, we're going to touch a little bit on group by and having. These are called the aggregate function. So what does it mean to have an aggregate function? Well, previously we talked about apply versus transform, right? Can anyone tell me what's the difference between apply versus transform in pandas? Did anyone remember that? I think it was in last week's material. Can anyone tell me that? What is the difference between apply versus transform? Anyone? Even vaguely. Any memory about apply versus transform? Any idea? No one? Okay, let me pull up the hint I have here. This is from week 6 of the session. Let me share this. So we have seen a similar type of question in week 6. So df(a) of mean is equal to df of a dot transform mean. Okay, the answer to this question is, if I copy and paste everything here, I will get a value error because transforming a mean, what does that gives me? If I want to assign d of a that mean equals to something, I need a pandas series, right? I need a 1 by 4 series. But d of a dot function is, yes, transform is invalid. Why is that the case? So transform, apply works here, but transform doesn't. Why is that the case? And also, you don't really need to do this. You can just run dot mean. It's actually more efficient this way. Why is that the case here? Well, because transform expect the input and output to have the same dimension, whereas apply could take whatever function you have. It doesn't need to have the same input and output dimension. What do I mean by that? Well, if you have a number of 1, 2, 3, and 4, your mean is going to be one number. It's not going to be four numbers. So that's what we mean by, okay, transformer doesn't work because your input is four numbers and you're expecting an output with also four number. That's what transform is expecting. On the other hand, apply doesn't have this requirement. And similar type of question would appear in, well, SQL as well. So notice this type of operation. Okay, I have department ID here. I have this department here. I have department ID. Where is it? It's here. Now, but the question is, okay, if I want every department, I want to have a max ID to have 40, 40, 40. I want department ID, department name, and max ID 40, 40, 40. Can I do it? Can I just run like, this is kind of nonsense, but anyway. Let's see. Can I just run like department ID, department name, from department? I got an error. Why? Well, that's because this one has four records. This one has four records. This one only has one number. This one is one number. Okay, you're telling me to do this like selecting this four numbers, and one number. What does that even mean? Like, should I fill in all of the records? Well, if you want to do that, you need to tell SQL explicitly, right? So this is the type of problem that might arise with aggregating function. Aggregating function will change the input and output dimension. And this is not all of the aggregating function. There are other of them. Okay, so if you really want to do this type of operations, you need to do something else. Put it that way. One way to do it is with window function. Let's see. Max dpt id over order by dpt id. I think this one. Yes. Hold on a second. Actually, I need a subquery should actually do this one. From department. Wait, what's the name of departments? Yes, I need to run a subquery to actually do that. Okay, so that's because, well, my max function is changing the dimension. So each time, so I'm telling it each time when I'm selecting, I'm running this query again. This will affect the query performance, but fundamentally, that's because these aggregating functions will change the input and output dimension. So when you're please take extra caution with aggregating function. And I was going to introduce having, but I think it's a little bit overboard. So I'm going to leave it here just now. And one interesting thing is that, well, you could also run SQL commands. I think I mentioned this before in pandas. So let's do this. So I could run something like this, right? Okay, what if I want something like, let's see, select all of the household with the let's say with a median income, let's say group by their median age. So let's say housing median age. So most importantly, most of the time when you're writing a group by command, let me just run a kind of like a demo for group by commands from this demo database. It's not a database, but a data frame. And let's say the maximum of their total rooms and the minimum of the total rooms of rooms. Let me just run this as a multi-line. Also, SQL has a slightly different preferred layout you could take a look at. Group by. Okay, I'm not going to execute it, just this having just now. Hold on, what do I have? Context of data, use data. This data frame. Okay, I'm going to do this. It's not allowing me to run this in pure pandas. Okay. This is housing. Do I have call? Okay, I'm going to set this equals to, yes, what is this table? Yes. Okay. Don't need this anymore, so I can run this. Group by, do I have anything? No such table. Thank you. It's called housing. Okay. So here I am, what is group by command is doing is that, okay, I am going to go through each of the distinct housing median age. Notice that. And then for each of them that has, okay, an age of 1, what is the minimum number of bedroom they have, maximum number of bedroom they have, what is the minimum number of bedroom they have. I could also change this into mean max room as mean room, just for visualization, just for better naming. And then each of that is going to have kind of the maximum bedroom if the housing median age is 1. The maximum bedroom if the housing median age is 2. This is a very common operation we want to do, right? We're trying to group them by certain criteria and then run analytics. Now, what if I want to run, okay, I only care about the rooms where let's say, the maximum bedroom is smaller than 10,000, where the max room is smaller than 10,000. I will have an error. Why? Wait, hold on. I already have max room. Is that because I'm aliasing? Can I just run this into max rooms? Does this fix the problem? The short answer is no. Don't I already have this thing out here? Well, the answer is, again, your SQL, the order of your SQL code is not equal to the actual order of code execution. In this particular case, where will be executed before the max function is run. So I couldn't really run this. That is why we need to introduce another thing called having. And this one will solve the problem. Having allows you to filter the result after the group by command. I should add this. Notice that where is executed before all the group by and aggregation. So if you want to filter by the result of aggregating function, aggregated values, you need to use having. Okay, this is one of the most common pivots, or one of the most common pitfall in SQL. I want to query something that's like maximum, minimum, or the count of something, but my where command isn't working. Why? Because where is executed before these things even exist internally for SQL. So you need to use having instead. Okay, please keep this idea in mind. So this week and next week, you're going to see a lot more about SQL. Hopefully you will have fun with that. And I think that's most of the SQL I want to cover today. Next week, we're going to introduce some more advanced SQL stuff. And also, this is conventional thing, but it doesn't really matter if you're writing the SQL like keyword in capital letter or lowercase letter. I personally prefer to write all of them in capitalized letter, but it doesn't really matter. You could run like everything in lowercase letter. It will still be valid. But personally, I like to run everything in uppercase, just so I know it's a keyword in SQL. Okay, I think that's most of what I want to cover for today's session. It's mostly about SQL, how to work with that. So to recapitulate a little bit, please keep in mind this architecture here. So Python and SQL are two different places in your computer executing different code. And a lot of this con and cursor stuff are basically you're using Python to tell SQL, okay, I want to execute this stuff. And a lot of those stuff will only be saved in SQL or available in SQL database. If you really need to use some of them, you need to fetch the result, unless you're kind of configuring it that slightly differently. Second, please keep this like basic join syntax in mind. There are a couple like online resources where you could run like quick exercises, multiple choice questions to check your understanding. I would say go to write a couple different queries with them. You will learn. It's not really that difficult to pick up, but it's a very common thing you will work with in future. Okay, I think that's all I want to cover for today. And finally, please keep in mind this having versus where. And remember, the order of your SQL code is not the actual order it's executed. Okay, whenever you want to query or filter something with max, mean, count, sum, average, or whatever, aggregating function, you need to use heading. This is kind of the most common like first mistake in SQL. And yeah, I think that's most of all I'm going to cover for today. I'll hang here for a few more minutes if you have any questions specifically. And yeah, that's all for the session.